Welcome to In the Workshop. How to charge your mobile phone using a model steam engine. Or better still, why would you want to charge your mobile phone using a model steam engine? Well, for this I think you need a little bit of imagination. So, in the middle of a zombie apocalypse, with hordes of very dangerous killer mutants wandering about all over the place, it might be a good idea to call the emergency services, but unfortunately the power is out and you can't plug your mobile phone into the wall socket to charge it up, so you're a bit stuck. There is a simple solution. You need a steam engine and a boiler and some of these. Oh yes, these are leather belts made by my friend Andrew at blackorchardleather.com, and of course you do need a small generator to drive with the steam engine using these leather belts. And if you've been watching my videos recently, you will notice that I've just rebuilt a small generator and it's ready for testing. I think possibly the pulley is going to be slightly too large, but I'll try it to start with. The leather belt fits okay. It's 5/8 of an inch in diameter, which is a bit on the small side for the size of the flywheel of a Stuart 5A that I'm going to test this generator with. A Stuart 5A steam engine is far too big for this generator, but it's very convenient. It's sat on the bench and it's got a nice large flywheel, so the belt's not going to slip off. But first of all, I need to make up a belt, and this is how I do it. I'm using some coarse sandpaper to first of all sand one side of the leather at one end and the other side of the leather at the other end, and this forms a tapered section of the piece of leather belt at each end. And once these two tapered end sections of the leather belt are stuck together, I will get a very strong joint. I'm using cyanoacrylate adhesive because it's quick and it's easy to use, but there are probably other adhesives that are better for this, that are more flexible. But just so I can get on with the video instead of sitting about for hours while the glue dries, I'm going to go with the cyanoacrylate adhesive. Looking at the generator in detail, here are the two USB sockets. There's a voltmeter in the middle and a 12-volt supply at the other side. But the question is it going to work? I've connected my small compressor to it, and here we go. Success! We have electricity coming out of the generator. The compressed air supply in my workshop comes from a very silent compressor, which is very useful for testing steam engines because the compressor makes very little noise, but the volume of compressed air available is very low, so the engine soon runs down. Whichever steam engine I finally use for generating this electricity, and it's probably going to be a Stuart Victoria, I don't want it to be racing away and wearing out prematurely just to charge my phone. And so what I'm doing at the moment is making a smaller pulley for the generator, and this will allow the engine to maintain the correct speed on the generator without running too fast. I'm making this pulley out of a piece of brass, and brass is not ideal because it's a very slippery metal. Steel's much better, but brass is much easier to machine, so I can make this test pulley very quickly indeed. Not quite as speedy as this though. The video editor allows me to speed up the video. The original generator pulley is a little bit wonky anyway. The hole down the centre isn't a good fit, so I'm going to make this a very good fit. It's a 5/16 of an inch diameter shaft on the generator, and here I'm reaming the hole to 5/16 of an inch. So this pulley should be a very accurate fit on the shaft on the generator. And don't forget, when you're reaming holes in pieces of metal, always run the lathe slowly. You get a more accurate size that way. Unlike the pulley that's currently fitted to the generator, which is a crown pulley, that just means that the pulley is turned so that it's larger in the middle than it is at the outer edges, and that holds the belt in position. But what I'm doing here is putting a step or a flange on each end of the pulley, which is not really as good because the flanges will wear the belt. But anyway, it will do for now. I'm not taking great care making this pulley. As far as I'm concerned, it's just a mock-up, a test pulley to see if the principle of a smaller pulley works. I'm threading it 2BA to take a 2BA grub screw to clamp it to the shaft. And I really had better hurry up. Looking out of the window, I noticed hordes of zombies have just eaten the man across the street. But hopefully I'll be able to charge my phone and phone the zombie control services to remove them. Although in this area it's sometimes difficult telling the difference between a zombie and a normal person. But more importantly for the moment, I need to fix the pulley that I've made onto the shaft of the generator. And it's a very good fit with no slop at all. unlike the man across the street who's looking very sloppy at the moment. And the question that you're all asking is this going to make a difference? Well, yes it is. The engine can go a lot slower. In my opinion, the engine is running too fast at the moment. At this speed, the generator is generating more than 12 volts. But in no time at all, the air pressure starts to diminish and the speed of the engine drops. As the air runs out, the engine gets slower and slower until no voltage is registering at all on the meter. Ideally, I just want the engine to run at a nice even speed. Not too fast and not too slow. So it's time now to plug in the charge lead, and as you can see, this is for a very old iPhone 4. I don't use it as a smartphone, I just pick it up when it makes a noise and I go, hello? Well, the bad news is my next door neighbour's cat has just become another victim of the zombie apocalypse, but the good news is my mobile phone is charging, and it's charging very well. This is still a bit fast, so I'm going to leave it running and see what the minimum speed is where the phone stops charging. It's still charging at this speed, and if I speed it up a little bit, it's charging at this speed. So I think the size of the pulley is about right for the job. Tension of the pulley is quite important. Too much tension and there's too much stress on the bearing on the generator, and the tension here is fine, unlike outside where the tension is much higher. My phone battery is now completely flat, but the generator is supplying enough power even at this low speed to reboot the device. And all I'm waiting for now is for the icons to appear on the screen, and then I'll be able to use the phone before the compressed air runs out. I know from experience how this engine runs under steam. On my small boiler it runs very well indeed, faster than this, so I will be having a steam up in the garden, hopefully when it's nice and cold so we get plenty of steam in the garden, and I'll try the phone again and see how good the generator is. Also, I'm going to try this generator on a Stuart Victoria too. By the way, there's nothing wrong with the phone. I know the screen keeps going blank. That's because the lockout is set to a very short time just to conserve power. To be honest, the voltage and current from this generator is very tiny, but it is only a model, it's not the real thing. I thought I might try it with this engine. This is a Stuart number 4. And it's not in bad condition, but it's not in good condition either. And for anyone who's interested, this is how you reverse the direction of a steam engine. And by that I don't mean a steam engine that's fitted with reversing gear. That would be too easy. I'm talking about an engine that isn't fitted with reversing gear. With the piston at top dead centre, the larger lobe of the eccentric, and that's the one that normally has the grub screw fitted in it, in this case it's an Allen cap head screw, should be at 90 degrees to the crank web. And all you have to do is slacken off the grub screw or the cap head screw, drop the engine to bottom dead centre, and put the eccentric lobe in exactly the same position as it was in the first place, and then the engine will go the other way. And then once you've set the eccentric to 90 degrees to the crank web, turn on the compressed air supply but only put a very small amount into the engine. Don't allow a lot of air into the engine, that would be dangerous, a definite health and safety. Never put your hand on a flywheel of a steam engine that's at top dead centre or bottom dead centre when there's a lot of pressure in there. That could prove dangerous. You only need sufficient compressed air so you can hear when the compressed air is admitted to the cylinder at each end of the stroke, and then make a fine adjustment of the eccentric's position so that the air is admitted just before the piston reaches top dead centre or bottom dead centre. This early admission is really desirable as it cushions all of the moving parts at each end of the stroke. I was so busy showing the camera how to reverse the direction of the steam engine, I never realised I don't need to reverse the direction of this steam engine, so now the generator is going backwards, hence nothing on the display. So as a punishment for being incompetent, and please read that as incompetent, not incontinent, I'm going to varnish the baseboard for the 504 boiler plant. As usual, I don't use a brush, I just use the cloth, and then I wipe it off. So I don't get a really varnished look, I just get almost a waxed look, if you like, but with the durability of polyurethane varnish. The main idea is to waterproof and oil-proof the board. So that's about it for this one. What I have to do now is just nip outside and clean up all the body parts. And here is my generator in action, in slow motion. Thanks for watching, and I hope you found it useful.